Hello students, here we are going to learn about dispersion. So dispersion is the name given to any effect wherein different components of the transmitted signal travel at the different velocity in fiber, arriving at a different time at the receiver side. So a signal traveled or the signal pulse launched into fiber arrives smeared at the other end as a consequences of this effect. So this spreading causes intersymbol interference, which in turn leads to the power penalties. The smear dispersion is a cumulative effect. The longer the link, the greater the amount of dispersion also this provide in the smear dispersion. So several form of dispersion arise in optical communication system. So first is a intermodal dispersion. So this particular intermodal dispersion arise only in multimode fiber where the different modes travel with the different velocities. So the link length in a multimode system is usually limited by intermodal dispersion and not by the loss. So the clearly that the intermodal dispersion is not a problem with the single mode fiber. So the next second is PMD, polarization mode dispersion. So the PMD arises because the fiber core is not perfectly circular, particularly in older installations. So therefore the different polarization of the signal travel with the different group of velocities. So PMD is proving that to be a serious impediment varies high-speed system operating at 10 Gbps bit rated and beyond. And the third one is a CD. The most important form of dispersion is known as a chromatic dispersion, which has a profound impact on the design of the single mode transmission system. So CD arises because the different frequency components of a pulse travel with the different group velocities in the fiber and thus arrives at the different times at the other end. So CD is a characteristics of fiber and the different fiber have different chromatic dispersion profile. So the dispersion compensation. So the dispersion management is a very important part in designing of the WDM transmission system since dispersion affect the penalty due to the various types of the fiber non-linearity. So several techniques to reduce the impact of the chromatic dispersion. One is external modulation in conjunction with the DFB laser. Second, the fiber with the small chromatic dispersion. And third one is a chromatic dispersion compensation. So according to that, the first alternative is commonly used in today's high-speed system. So the new builds over the past few were used the NZDSF, non-zero dispersion shifted fiber that have small chromatic dispersion value in the C band also. So the dispersion compensation can be employed when external modulation alone is not sufficient to reduce the chromatic dispersion penalty on the installed fiber type. So for that two most important method, popular method use the dispersion compensating fiber and the chip fiber bracket gratings. So the diagram of the chromatic dispersion in the WDM system. So the first case is the chromatic dispersion at each point along the fiber provided in the case, and this case is the second case is the accumulated chromatic dispersion from the beginning of the link up to the reach point along the particular fiber.